taught the regulars and I taught synthetic division. So synthetic division is a nice, easy way to divide out your polynomials. Otherwise, you're going to do a long divide. So, and we really don't want to stop. It allows you to see a pattern even better than I could explain it because it's got the little arrows in here. So we're going to start with this polynomial and we're going to divide it by that binomial. Now remember, when you divide, if you reduce your factors, isn't this a factor? It's not a zero, it's a factor. So technically, I'm going to set it equal to 0 and find out what my 0 is. And all the time we do this, the leading coefficient of whatever our denominator is has to be 1. Or we're going to have to factor it out like we did in your complete the square. Whenever we have 2 terms, it has to be 1. And if it's 3 terms, the leading one has to be 1 for us to start. So we're going to start like this. And do this with me because you have this paper. We're going to pull out all your leading coefficients. Now, if a term is missing, you put a 0 in there. In other words, this started with 4. This is going to have 4 zeros. 4, 3 is missing. So we need a 0, x cubed. 2, 1, this is really x to the 0. So we've got to pull out all those leading coefficients. So 1, 0, negative 10, negative 2, 4. Just pull out your coefficients. And before you start, run them down. And x to the 4th, so 4, 3, 2, 1, 0. If they don't go to 0, you missed one. And if you do the whole entire thing and then you realize, whoops, I missed a 0, you got to erase it and do the whole thing over again. Now here's your pattern. If I cover this, you see everything goes down, multiplies to the right, down, multiplies to the right, down, multiplies to the right. This is your pattern for synthetic division. First time through, you're going to bring this guy down. We have no place to start otherwise. And now we're going to multiply. Negative 3 times 1, and we put it up here to the right, negative 3. Then add down. 0 plus negative 3, negative 3. Then multiply. Negative 3 times negative 3 to the right.
What?
9. See the pattern? We're multiplying to the right, multiply to the right, multiply to the right, multiply to the right.
So then it'd be negative 10 minus 1?
And what would that be?
Negative 19?
No, add them together. Add them, you're combining your right terms. No, it's negative 10 plus 9. Negative 1. Right now, multiply. Negative 3 times negative 1 is 3 to the right. What is negative 2 plus 3? 1. Multiply. Negative 3 times 1.
3.
Negative 3. To the right. Not really. Add them down. 1. Here's your coefficients and your remainder. Now, easiest way to figure out what it means is this. Look at your front end division. Front end. Your highest exponent on the top, your highest exponent in the denominator. So it's x4 over x1. Say it real simple. When you divide, what are you going to start with? What's x4 divided by x1? X3. You subtract. Say it real simple. So this is your x cubed. 2, 1, 0. We exhausted it. This must be your remainder. Now all we're going to do is put the coefficients back in. X cubed minus 3x squared minus x plus 1. Now, this is your factor, but we've got a remainder. Put a plus, and then put this guy over the denominator, just like we did with the 5 up there. They don't all come out even. You know, just like your regular divisions, they don't all come out even. Tomorrow, we're going to see what happens when this remainder is a 0. When this remainder is a 0, then this in fact is a real 0. This, whatever we're dividing by, would be a real zero. This one's not, because its remainder is not zero. So today we're just learning the steps of synthetic division. I just want you to get the steps down pat. Do you see the pattern though? Multiply to the right, multiply to the right, multiply to the right. It's constant. Multiply to the right, multiply to the right.
I must have not been paying attention, but how do you get the negative 3 from...
The negative 3 comes out of here. It's your 0. Those are factors right now. So if we set your factor equal to 0, then that's your root. Remember how you end up with a bunch of factors and you set them equal to 0? Those are your zeros, your roots of your equation. All right. Ready to try another one? All right, we're going to try another one. Before we try the one that's on the paper, I want to try one more. And I want to use this pattern. 2x. Oh, no, let's make this a 3. Sorry, it's not 3. Okay. How do I start? Okay, set this guy equal to 0. Is the leading coefficient 1? So we can set this equal to 0. And we know one of the zeros, one of the factors to this. And we know this is a factor. Okay, so now, what's the next step? Get the leading coefficients. So we've got a 2, then a negative 4.
0.
Then a 0.
Negative 5.
Yes, so now let's see if this works. 3, 2, 1, 0. Good. There's no x to the 1 power. X to the first power. So we're going to set this up like this. You make a little L like this. And you put your 0 right here. Your factor. Set equal to 0. Now if you look at this, really where do I start? There's no starting place. There's no place for me to start multiplying. There's nothing on the bottom. So that's why we drop this one down. And now we start multiplying. You always read your problems left to right. You read your words left to right. So you do this left to right. What's 3 times 2?
6.
6. To the right. Add down.
2.
2. Do it again. 3 times 2.
6.
6. To the right. 6.
6.
3 times 6.
18.
To the right.
13.
Add down.
13.
Okay, now, front end. Just say it real simple. Just look at the x's. x3 over x1.
X3.
x2. x3 over x1. Remember your subtraction numerator, your exponents. So that's why I'm saying say it real simple to yourself.
Oh.
Real simple. 3 over 1, we're going to subtract those. So you're going to start with an x squared, an x1, an x0. Whoop, remainder. That's fine. Sorry. That's a 13. Okay, so now, just plug it in. 2x squared plus 2x plus 6 plus 13 over x minus 3, your denominator. If it helps, I like to put parentheses around that so it doesn't get mixed up with everything else. Because you tend to, if you write it all at once, you tend not to remember where to put the line for the denominator. Yes?
So the last number should always be the remainder?
The last number will be the remainder. Will it always be a number? Sometimes it will be a 0. Like tomorrow we'll see when there's zeros. Those are the real zeros of our equations. So right now that last one, for a simple one like this, will be a remainder. We're about to do, when we do a double one, there might be 2 numbers out there. But for a simple one like this, that's where your remainder will be. But it could also be a 0. And in which case, if this came down to be a 0, we leave that out, and this is a factor. And our goal eventually is to factor and factor until we can factor out the zeros, until we can get something that would be factorable, that we can factor. But for today, we're just learning the synthetic division part. Oops. see if I can start this again. All right. Now, of course, we throw a little curveball in. There's two terms in your denominator, but the leading coefficient is not 1. It can be. So remember how you did this when your leading coefficient, when you completed the square wasn't 1? What did you do? You stopped because you didn't want to have to do any fractions. Yes. You factored it out. So now, we're going to take this, we're going to factor out a 3. And we're going to still set it equal to 0. Okay? And we're going to divide by 3. Now, put a little asterisk next to this guy. Divide by 3. Because if you divided this thing by 3, when you get to the very end, you also have to divide that by 3. This is your root or your 0. That's the guy that's going out here. And it's okay that it's a fraction. It'll work itself out, trust me. Now we pull out your coefficients. What would they be?
6, and then 16, 17, -6.
Good. Okay. Now notice, we don't have a starting point, so we drag this one down. And we go left to right. You're coming from the left, going to the right. 2/3 times 6, and we put it to the right. 4. So 3 goes into 6 2 times 2 in the numerator, 4. If you're doing this, 2/3 times 6, 3 goes into 6 2 times 4. 2 times 2 is 4. Now, add it down. What do you get? -12. Again, 2/3 times -12 to the right. -8. So if you want to put your negative there ahead of time before you start, 3 goes into 12 4 times, times 2, 8. Add it down. 9. One more through. 2/3 times 9 to the right. 6. 3 goes into 9 3 times, times 2. 6. Ah,
I use your calculator for
well, to do those multiplications? No. Add this down, and what do you get? 0. So now we have a remainder of 0 out here. Okay? So how do I know that's my remainder? I'm going to count my terms down in a minute. But I have this little asterisk here telling me that I divided by 3. So I got to come down here and divide everybody by 3. It's easier to do it here than before you put your x's in. So 2, -4, 3, and 0. Say 0. So look at your x's in your front end and say it very simple. x3 over x1. What are you going to start with? X squared. So 2x squared minus 4x plus 3, remainder 0. Remainder 0. That means this, and we'll see this tomorrow, this is the real 0 for this, because our remainder came out of 0. So our other factor to this would be 2x squared minus 4x plus 3. If we want to find the other two zeros, we know there has to be 3 altogether because your exponents have 3, right? This was 1. Now is this factorable? We're into an x squared? Yeah, even if we had to use your quadratic or complete the square, it still is factorable. So our goal tomorrow will be to get down to a square so then we can factor it. Our goal today is just the synthetic division part. Now, does it sound familiar to anybody that did this?
No.
Still no?
Close.
Not at all.
I think close.
I remember doing this
This
last
is
week.
like shape one one.
It's like
This
four
kid
language
did it.
figuring it out.
All right, now, here's the third situation. How many terms are in my denominator?
3.
3. Is the leading coefficient 1?
No.
Leading of all of the things. Leading, high. Well, your highest exponent is 2. This is your leading exponent. There's your 1. Oops. There's your 1. So your leading coefficient is 1. Now, we could only use the last 2 positions. So this is what we're going to do for this guy. We're going to pull these out. This is 1, so we're okay. You only can use the last 2. We're going to pull these out both together. We're going to make a double divisor, and it comes out the opposite way. Like you saw x plus 3 came out negative 3, and the one with the negative came out positive. So this is going to come out to be a 3, and this is going to come out to be a negative 1. I still read left to right, didn't I? Don't you normally read left to right? Just do what you're normally used to doing, left to right. Pull them out the opposite way. Pull out your coefficients. What's your coefficients?
1, -2, 5, 0.
0. Good. So try this. 3, 2, 1, 0. You got them all. Now, the first time through, all I want you to do is watch me. I don't want you to write. Because what happens when you write, you don't see the whole thing. Then I'll do it again, and you can write it down and go a little slower. But I want you to see it has the same pattern, but we just have to do it double. So I bring this down. Easiest way to remember, you read left to right. So start with the left one, and you put your products to the right. 3 times 1 is what?
3.
3. I have another guy. Negative 1 times 1 is negative 1. But I got to go to the right of this. I keep going to the right. Negative 1. And I stop. I only add down the column that's next to the one I just completed. What's negative 2 plus 3?
1.
1. Right? Now, I start my process again. The only different thing was I had 2 of them to do, not 1. I had to do 2. But my rule is multiply to the right, multiply to the right. And now I do it again. 3 times 1 is
3.
3, to the right. Negative 1 times 1 is negative 1, to the right of this. I stop because I completed these, and this time around, I'm at the end of my top, my lines up top. Yeah. So now I combine everything. What is a 5, a negative 1, and a 3?
Wait.
7.
7.
And this brings down negative 1. Now, this is front end. X3 over X2. Just X. So this would be X1, X0. This now is a remainder. Start the remainder backwards. This has to be your X0. This is going to be your X1. So we write it out. 1x plus 1 plus, put your remainder, and then put this in parentheses. Now, always put the plus. Because what happens is, if this guy was a negative, and you put the negative 7 minus 1, you're going to miss this sign of the second one. So put the plus, then put this guy over here. 7x minus 1, we said x1, over that denominator. Okay? So I'm going to work it through so you can write it all down. Process pretty much the same. You're multiplying from the left, moving it to the right. But you have 2 divisors to go through. So if you do the 3, you got to do the negative 1. It's got to move to the right. When you stop, you only add the 1 down next to the one that was there already. Ready? We'll do it again. This time, right with me. Okay? We agreed that this was a 1. So we're going to take these out the opposite way. Left to right. 3, negative 1. You pulled your coefficients out. This is where you all put your pens down. So let's start. Bring this guy down. 1. Now, sometimes it's easy to make the arrows. Just don't make too many things over itself or it's confusing. 3 times 1 is what?
3.
To the right. You got another divisor. Negative 1 times 1 is what?
Negative 1.
To the right of this guy. Stop. We did both of these. We checked them off. Add the one up that's closest to the one that's there. So negative 2 plus 3 is 1. That's it. Do it again, because now you got a new number down here to multiply with. So 3 times 1 is to the right. Negative 1 times 1 is negative 1 to the right. Now you've exhausted those two and you reach the end of your rows there. So now add everything down. So 7, negative 1. Did I lose anybody? Until you try it yourself. Everybody does this with me, then they go home. They come back the next day and say, I couldn't remember what we had to do.
Exactly.
Yeah, but it's the same pattern over and over. You bring it down, multiply to the right, multiply to the right, add 1 down. Do the process again. So your front end says x3 over x2 gives me x1. 1x plus 1, this is your remainder. This is your 0, this is your 1. Plus 7x minus 1 over your denominator. And that's your remainder.